Containers have been around for a long time in the Linux operating system. Microsoft just added this capability in their latest version of the Windows Server 2016 operating system and also in Windows 10 Anniversary Edition. Containers are part of the operating system, and on top of this you install the tooling that can work with containers. It is important to understand that the container image is always targeted at a specific operating system, since containers share the operating system kernel. It is hopefully obvious that a Linux-based container image cannot be run on Windows, and a Windows-based image cannot be run on Linux. So container images are always targeted at the operating system that will host them. To make things a little bit more confusing for you, you can also work with Linux containers on Windows. For this you can install the tools called Docker for Windows. This tool adds a Linux virtual machine that can be run in Hyper-V to the machine. And this gives you then a tray icon that you can then select to switch between Windows or Linux containers. This tool is primarily targeted to developers and not for a hosting environment of containers. For developers it's very convenient that they can switch between platforms. But it's very important to keep very close eye on the fact that you're targeting either a Linux image or a Windows image. The trick used by the tool is just hosting a Linux container inside the Linux virtual machine. And then that runs on the developer machine, and they rewire the command line tools so they talk to the Linux machine instead of the Windows machine. Now let's have a look at how containers work on Windows. Windows is a highly integrated operating system, and therefore Windows always needs to start a couple of extra processes for each container when it starts. You see in the diagram that the base operating system has a process running in host user mode. Those processes are required by the other processes on Windows. The moment you start a Windows container, you can always get some of these extra host processes running on your machine to facilitate the running container. You see in this diagram that we have a green triangle. That's my application now running in a container on the host, sharing the Windows kernel. Now when I add a new container, I again get a set of instances of these processes plus my own process. Those are created by my application. In this diagram, the purple round and the Azure blue square are my processes. Windows has, besides normal containers, also the notion of Hyper-V containers. The idea behind this comes from the fact that sharing the kernel on the operating system might be unsafe if you have an operating system with a zero-day exploit that's not yet fixed. This is not really a problem the moment you host your own created containers on your own machines managed by yourself. But imagine if you run a public cloud business and you want to host images of third parties and you cannot tell if one of those containers has hostile intentions to break out of the container and access the host or other containers. For this, Microsoft created Hyper-V containers. Hyper-V containers run in a container in a very specialized and optimized virtual machine that is in its turn running a container. The extra level of isolation provides additional security, and this is very welcome if you host containers that you don't control yourself.